I'm really honored, and it's my pleasure to introduce Mr. John Slaughter, who is the director of UAS Research Operations Center. It's part of the A.J. Clark School of Engineering and AJMs. We have actually, some of us in the past have been in the site. It is located at California, Maryland, in Southern Maryland. And John actually became the director last August of 2022. Before that, we worked with Mr. Matt Cicero and so forth. It's a great place. They have lots of opportunities. But a little bit about John. John, I was just asking him, I don't have a formal biography at hand to introduce him. He really has had an amazing track record. He starts in Berkeley with history major, goes to his master's in project management or engineering management, systems management, and then goes to Navy for almost 30 years, Navy pilot. And then after 30 years of being in Navy, he goes into basically small business. Although in Navy, you had a group was like almost 400 some people that you built that infrastructure for flights and so on and so forth. Lots of information gathering and many other missions and stuff that he has been involved. It's really intriguing. And so after all that great experience and so forth, he joined we are lucky to have him in our UAS, systems operation research and in California, Maryland. And, he has been telling me that they have lots of opportunities also for students for internships, summer internship and stuff. So please spread the word. So we can get in touch with John if there are opportunities, if they are interested, hopefully we can link them. So with that, John, please, I know that it was brief, say whatever else you want to say about your background. It is good, for our colleagues to get to know you. Of course, we can establish research collaborations as well as the, student internships and many other things that are important. Please, all yours.
All right. Well, good afternoon. So, as noted, John Slaughter. So, just want to, unfortunately, just start out. There we go. Okay, I started out, as noted, that's a little bit of Navy helicopter humor there, okay? But so I was a Navy helicopter pilot after college. Spent about 29 and a half years. Flew helicopters all over the world, all kinds of aircraft carriers and other ships. Commanded a couple squadrons, one fleet, one test squadron at Pax River. And Texas River Naval Air Station down in Southern Maryland. Ended up down there, spent about 10 years in naval aviation acquisition. So helping to specify the next generation of Navy helicopters, and then helping to go out and make the acquisitions of those, involved in flight test of those helicopters, also wrapped up as the military director for systems engineering at the Naval Air Warfare Center down in Jackson River. And after that, retired 2012, joined a small company just outside the gate down there and worked with them, where I did a little bit of advising and consulting back onto the base, and also helped that company grow. So I was in industry for about 10 years. And then this opportunity presented itself last year around this time. And I joined the University of Maryland in August. It's been a great ride so far. So, a little bit about you. I just wanted to ask if anybody in this room has a drone, any kind of a drone, small one, little hobbyist type of thing. Okay. All right. Very good. Any kind of FAA certifications that you happen to have done? Anybody familiar with those? We'll talk about those a little bit. If you've used one for other than commercial purposes or recreational purposes, you should have an FAA qualification. If anyone had any of that experience, we could talk about this a little bit, but I'm going to talk some about it myself. So we'll kind of just move along. So topics today, what are drones? What are they all about? What are we using them for? What are they good for? Good for a lot of things. Why aren't they everywhere yet? So we've been reading now for 10, 15 years about how these things are going to be dropping off packages on our doorsteps. They're going to be everywhere. Ubiquitous, doing everything. They're not. Why? So we're going to talk about that a little bit. And then what's going on, efforts that are happening a bit to try to get there, to try to make that situation a little bit different. And then finally, I'm going to talk about how the University of Maryland fits into this, and specifically about the UROC in Southern Maryland and our role. Right. Okay. So what are they? So uncrewed, unmanned aerial systems, aircraft systems. The acronym can be a little fuzzy. People say it a lot of different ways. And then the vehicles themselves that go up in the air. So what are some of these things? That is a Reaper. So if you've been reading the news yesterday, there was a little run-in between one of these and some Russian fighters over near Ukraine. The Reaper wound up in the water. The Russian jet wound up with its nose chopped up by that propeller you see on the back of that thing. And now the recriminations are flying. That is a little hummingbird UAV that was designed by the Defense Advanced Research Projects Agency, but it's about 10 years or so old. I think that our own president here, Gail Pines, was a part of this project. This is a Kettering bug. So these things go back a long time ago. This was designed and operated during World War I. This is in the Air Force Museum. So uncrewed, unmanned aircraft have been around for a very long time. This was obviously pretty unsophisticated. Anybody recognize that face? So that's those are target drones. That's Marilyn Monroe. So that's working at the radio plane manufacturing company in Burbank, California. That's where she was working when she was discovered during a World War II fundraising event. They come in all shapes and sizes. So some of them look like typical helicopters, kind of like what I flew, just a lot smaller. Nobody in them. This is, if you're not familiar, this is one of Google Wings delivery drones. So obviously a very different looking kind of thing than you're probably accustomed to. They can come pretty big. This is the Navy's onboard aircraft carrier launch and recover refueling platform, the MQ-25. So this thing is groundbreaking in many ways. First ever to launch and recover from aircraft carriers, and they're getting ready to deploy those. Pretty large airplane, as you can see, but even bigger they can go. This is the Navy's Triton. This thing has got a wingspan around the size of a 737. And so these things come all the way from that little hummingbird sitting in the palm of someone's hand all the way up, and they're flying on Mars as well. So this is, the UAV that's flying on Mars actually had a little bit of its genesis here at the University of Maryland too. So aerospace engineering was involved with the very early kind of work that went around the drone up there. So what are they made up of? So uncrewed aircraft systems, that's the term we use, are made up primarily of the UAVs. Those are the air vehicles and all of the systems that they carry, including the payloads. And keep in mind that what these things typically are is really a truck. Okay, maybe a little one and maybe a big one, but it's those payloads, the things that they're carrying, the sensors. That's what the real business of these things are, generally speaking. The data links, and one of those data links connect them to the ground control station. So the system can't run without all three of these pieces. Often there are other pieces, but this is a minimal UAS. And then there's a human in the loop. So today we don't have fully autonomous systems. We're working on them. There's a lot of development going on. One of the projects the UROC is working with the Robotics Center here and Aerospace Engineering with the Army Research Lab up at Aberdeen is a project called Artificial Intelligence and Autonomy in Multi-Agent Systems. So think of swarms of drones, all intercommunicating and planning their own searches and coordinating their activities. They come in a lot of different shapes. This is a multi-copter. This is one of ours down at the UROC. This is about 5 feet across from rotor tip to rotor tip, up to around 55 pounds. A single rotor type helicopter. You'll see fixed wing. This is one of our Penguin VTOL, our Penguin aircraft down at the UROC. Needs a runway, as you can see from the wheels. And this is another version of that aircraft. And we're in the process right now of converting our runway launch and recover to this, which has got the quadcopter type takeoff and landing motors, and then it converts to a pusher fixed wing aircraft for greater endurance. They come in all sorts of different sizes, and I'm not going to read all these groups to you, but they are broken out for convenience into these various groups 1 through 5. And this is a shot, just a snapshot in time of our flight ramp at St. Mary's County Airport down in Southern Maryland. Some of those aircraft are gone now. A lot of those gray tiger sharks have moved on to the university out in New Mexico. The one in University of Maryland livery is going up in the museum down there, the Peckham River Naval Air Museum. And then there are just a sort of a snapshot of time, some of the ones that we've got. So what do you use on crewed aircraft? UASs, we commonly talk about the 3Ds, dull, dirty, dangerous jobs. That's what those things are ideal for. When you think about it, some things are kind of dull. It's kind of boring to fly back and forth, staring down at the ground and trying to see what might have changed. Drones don't get bored. So drones are really good for dull jobs. Dirty jobs, things like getting into getting into sewer pipes and inspecting them. People got to do that stuff right now, but drones can fly in there. Think about the stacks on a power plant. So right now we got to shut down the power plant, lower humans down into those stacks on ropes to go inspect them. You can do those with aircraft. You could think about a contaminated area, hazardous materials. You could think about in the aftermath of a natural disaster. A lot of applications in dangerous situations and dirty situations for drones. Precision is another utility for these. So they're great for things that require precision. As a Navy helicopter pilot, I was often involved with search and rescue. And when you're looking for something in the water or elsewhere, flying very precise patterns across that surface is key so that you don't miss anything. But humans are inherently have a hard time with that. It gets boring, first of all, as I mentioned before, see the dull part. And also it's just the control inputs that it takes to stay over those patterns, in those patterns in wind and rain and other kind of inclement factors can be challenging. Drones don't have that problem. They are extremely precise. Surveying, similar issue. So precision jobs are really good for drones. Precision agriculture is a common application. Speed, getting supplies, medical supplies to places can be really important. There's a company called Zipline, if you've ever heard about them. They have hundreds of operations a day in both Ghana and they're over in other countries in Africa, but they're running medical supplies, prescriptions, blood, plasma. They're making hundreds of deliveries a day to areas that would take hours, if not days, to get through other means. And they can do it, in a matter of minutes, if not, perhaps an hour. Cost, they're cheap compared to crewed aircraft. Manned aircraft are very expensive. A lot of the cost of that is the life support systems it takes to keep the pilots alive, frankly. You go to altitude, you need oxygen. You need all those survival equipment. So it takes weight, it takes power, it takes cost. So you can take a lot of that out with drones. And then recreation are pretty fun. So people use them for all kinds of stuff, whether that's, a lot of the little consumer things that you got, like the one I own, they're basically cameras that fly and they really do need stuff for that. So who's using them? So the military, as we all know, are pretty extensive users of these, and they use them for everything from, reconnaissance, intelligence gathering, all the way up to delivery of ordnance. I think you've all probably seen that, read that. They're used for all sorts of applications. They are great for inspections of difficult to access areas, called those buildings, bridges, other kinds of infrastructure. They are good for those agricultural applications over flying fields, taking measurements, doing surveying work. They're used all over the place. Recreational, talked about that a little bit. But the bottom line is with them that everything right now that is being done legally anyway with drones is generally bounded by some pretty constraining rules. And flying them into the National Airspace System, which is everything from the ground up, FAA owns it, and the FAA has the rules, Federal Aviation Administration, on how that gets done. And so why haven't we got there yet? Why have we not seen these showing up on our doorsteps yet? Why do we not see cargo being delivered between airports using these? That's the question, isn't it? And it's really the FAA. And so FAA is an organization which is founded in safety. It's aviation safety. Safety belongs in aviation. That's the first thing we think about as aviators is, can we do this mission safely? And if not, how can we do it more safely? And they have their reasons for why they look at that. And they are fundamentally focused on manned aircraft. That's what they've done throughout their history. And so they tend to put rules on uncrewed aircraft that are the same, just as stringent as those for manned, but sometimes they just don't quite add up. You know, if you want to get a certification for the design of a UAS, you're going to go through the same wickets that you will to get that certification for a 737 passenger jet. Just doesn't quite make sense in all cases. They're struggling with that. They've been struggling with it for a very long time. And there are other analogous situations. It all comes down really at the end of the day to, can we trust these things that don't have humans in them? And if you think about it, you know, aviation today and always has fundamentally been based in what we call seeing the movie. All right. If I see an aircraft over there and it looks like we're on a collision course, you know, in the interest of self-preservation, I'm going to do something. I'm going to make a turn, I'm going to climb, I'm going to dive, and probably so is whoever's driving that other one. So if I don't have a human in one of these things, how do I know it's going to do that? Or how do I know what it's going to do? So there's a fundamental trust problem with all autonomous systems. And that's one of the major challenges with these being introduced into all walks of life. And so fundamentally, what the FAA tends to want to see is proof of safety. And if you really get down to that, you're proving negatives. And that's pretty hard to do. And so they're looking for more and more and more. So typically, the safety cases will be constructed. A safety case, you know, will analyze a use for a system and then show the potential risks and then attempt to demonstrate how those risks are mitigated down to an acceptable level. The problem we come in with FAA is we'll bring that in, that fully well thought out and analyzed risk case, and they'll say, yeah, but did you think of that? And then you're back to the drawing board again. So that kind of a back and forth, we call that bring me a rock. No, I don't like that rock, bring me another one. And we see a lot of that. So working with that is one of the challenges. It's not really the technology that we're looking at. Most of the technology is there to do these things. So for instance, with my airborne collision example, radars can help with that. And there's certainly algorithms that can be written to calculate the closure rates and the flight paths and determine how we can potentially avoid a problem. But that isn't good enough. Not all these things can carry it. So smaller aircraft things have been done as well. So down to that zipline company I told you about, the ones delivering over in Ghana. So they have acoustic detectors they're using, believe it or not, listening for other aircraft and then triangulating the location of those, calculating flight paths, and using that to perform collision avoidance. They've been using it in Africa for many, many, many years. FAA is not buying into it for use in the United States. Not yet. They're working on it. So technologies tend to be there, but it's really about the standards and the regulations that keep getting us. So those standard and regulations, again, as I had mentioned, they're developed for manned aircraft. They just work. I mean, that's what FAA has done, you know, ever since shortly after the Wright brothers and its various iterations until it finally got, you know, named FAA. That's what they've been doing. And so they do a great job of that. We have an incredibly safe system. Sometimes it gets a little backed up. I think I spent some extra time in airports at the holidays. I know I got to spend a morning in the airport when, if you remember, the NOTAM system went down in the middle of January. But, you know, it's all there for a reason, and it does keep us safe when we go climb on those airliners and go fly. That's a big deal. How can we also peacefully share the air with these uncrewed systems? So what we're up against here is dealing with change. Change is perceived by the regulators as risk, and they really don't like risk. In fact, you know, we tend to talk in aviation about risk management all the time because there's no eliminating. You know, safety is about, fundamentally is about managing risk. If you try to avoid it completely, however, you don't get to go anywhere. You never get out of bed anymore. And that's one of the challenges we're up against is the idea that we can somehow you know, really take almost all the risk out of something. So some of the areas that are around this, that are being worked on today, you know, artificial intelligence, machine learning, autonomy is a huge part of what's going on in the drone world today and the research that's going on. So how do we reduce human workloads? How can we get aircraft uncrewed aircraft to work together. When we say UXS, that may be an uncrewed aircraft working with a ground vehicle or perhaps an uncrewed boat. And that is also a very useful implementation. So we see that kind of work going on. I talked about trust. So getting to a place of trusted autonomy where we can demonstrate and prove through testing that what's going to happen when a given situation occurs is going to make the right decisions. And we can show that repeatedly enough to satisfy the regulators. Airborne detect and avoid. You talked about radar being useful for this. So seeing what's out there and then taking the right avoidance maneuvers. But what other technologies can be developed that can do that in a smaller, lighter, and cheaper package? And that's the critical part for these smaller UASs getting up and away. BVLOS stands for beyond visual line of sight. One of the rules that really holds back drones today is the FAA rule under the Part 107, as we refer to it. That's Part 107 of the Federal Aviation Regulations, and that governs UASs. So got to fly them below 400 feet. Can't be more than 55 pounds. And the operator has to have visual line of sight contact with them throughout their flight, take off the land. That means you really can't do anything with a typical drone that's maybe more than a mile away without moving your base of operation or coming up with a workaround. So BVLOS research would really depend on these technologies that are being developed for detect and avoid autonomously and take the right steps to avoid. A lot of that's ground-based now, using ground-based radars. There are machine vision-based systems for this. There's a lot of research going on in the realm and development in the realm of detect and avoid. And then precision navigation in areas where you don't have GPS. And so this could be underground, in caves, mines, inside of buildings, those kinds of places. It could also be in an environment, a combat environment where GPS is being jammed. But you need to be able to navigate precisely in order to safely operate. So what's going on? I already mentioned Africa. That's a place where there is a lot of work going on with UAS. A lot less, manned aircraft flying in Africa. So there's less risk of mid-air collision. A lot of unpopulated areas where the aircraft can be routed such that there is less risk of following on something if something bad does happen. So proving concepts, building up hours, hundreds of thousands of hours to prove use cases happening elsewhere in the world. Here in the US, industry is really driving hard. You've probably read about companies like Google Wing, Amazon Prime Air, which you may have also noticed is kind of scaled back a little bit. There are, Walmart is working with Zipline, the company that I mentioned before. So there are a number of efforts going on in the United States to try to push the limits, push things forward. The FAA itself, working with NASA, has done a lot of work in response, really, to kind of being beaten over the head and shoulders by Congress to try to get around this problem or get working on this problem. So they've got some designated FAA UAS test sites around the nation, mostly rural areas, places like North Dakota, Alaska, West Texas, Oklahoma, where they're doing a lot of research on these problems that are in front of us. And then there's independent efforts, and that's where we come in down there at UMD UROC. So that's kind of the first half of this brief, talking about drones in general. And I'm going to kind of zero in a little bit about us. And so the UAS Research and Operations Center, about 8 years old, down at St. Mary's County Airport, so about an hour's drive, hour and 15 minutes south of here, down near Patuxent River Naval Air Station. If you're looking for us on a map, what you would do is follow Route 4 down or follow Route 5 all the way down to you hit the Chesapeake Bay, and we're pretty much down there, right between the Patuxent River and the Potomac. So our first part of our mission is research and education. So we support faculty, we support students, we have equipment, we have experience, and we have expertise, and we bring all those things to bear to help make projects go smoothly. We support operational activities, by which I mean public and private entities. These might be organizations like National Oceanographic and Atmospheric. We just shipped a drone up to Alaska yesterday. We have one of our teams is heading up to Nome, Alaska in 2 weeks, where they're participating in the third year of an ongoing project with NOAA to measure sea ice thickness. They're using satellite payloads to take those measurements today. However, the calibration of those satellites is a challenge for them. They're done manually, so they run humans out on the ice with handheld measuring devices, core drilling, to try to calibrate and measure and correlate the accuracy of those satellite payloads. So the thought here is by using hyperspectral sensors and using multiple wavelengths of light, we can get data that the scientists can then convert to useful information and somehow, don't ask me how they're doing it, but they are getting these measurements. Last winter, we were up on Lake Michigan in the winter, taking these measurements. They were ecstatic with the data they got. So this year, it's off to the real sea ice up there off Nome, Alaska.
Mhm.
So that's one of the kind of public projects we've worked on recently. We've also worked with private industry. So we've got another one coming up here very shortly. So this could be anything from airframes. So someone has built a new drone and they want a little bit of help with fine tuning it, perhaps the software and the autopilots, maybe the airframe itself and the aerodynamic aspects of it. So we've done that sort of project, but oftentimes it's around using, just taking a payload up and seeing how that works, or helping them to test the payload and the function of the payload. We were reached out to about a month and a half ago by a company called Astrobotic. Anybody ever hear of them? Astrobotic is actually launching a lunar lander this month. So they're one of 3 commercial companies that are getting ready to launch to the moon with landers. And they came to us about assessing a technology for looking down as the systems descend and improving, their ability to land on the moon is what we're taking it to mean. Anyway, they're coming out. We're going to be testing that system for them down in Southern Maryland in middle of April. And then long-term initiatives. So back to the rules, back to trying to get UASs up into the National Airspace System. So Chesapeake UAS route network, talk about that a little more too. But the idea here is let's build a network of routes that overlay the state of Maryland that we can use to get from point A to point B and do it as safely as possible and hopefully start pushing the envelope on some of these FAA rules. Beyond visual line of sight, the size of the aircraft, mixing crewed and uncrewed aircraft in the air together, those kinds of things. So what are we using? These are some of the aircraft we've got right now, and they do kind of come and they go. All right, so we've got a number of things in here. This is a tiger shark. We're not really using these anymore. They're large, they're kind of old, they're not real reliable. This is a penguin. This one we're converting right now into vertical takeoff and landing. That's going to be a major part of this Chesapeake UAS route network research that's coming up shortly. This is a Puma. It's a typical, lightweight, inexpensive military drone. We've used it for long endurance testing. A couple of summers ago, we put some solar panels on that wing. It's a battery-powered aircraft. We were able to effectively triple the endurance through the use of solar power and live recharging those batteries on the fly, as it were. This aircraft here was involved with a project back in 2019. That was the first ever live kidney transplant that was facilitated by a drone. That was done up here in Baltimore. It was a collaboration between our aerospace college, our department, and also the medical professionals up in Baltimore. And so what they ended up doing was developing a bunch of technology that was used to both fly it, so a brand new custom drone to carry it, and some of the packaging that was used to carry it and make sure we monitored that drone while it was en route. All that was created for this project. Got a bit of publicity back in its day. And so we got a lot of different aircraft, a lot of different sizes. So what do? To a research project, we can bring equipment, just showed you some of that, but just as important, more important really, is the expertise. So we have engineers and pilots with thousands of hours flying UAS all over the world that can be leveraged. We have expertise dealing with FAA and just about everything, whether that's getting what we call waivers to the rules, certificates of authorization and waiver, which is establishing chunks of airspace for use. So we can do a lot of things. So I mentioned the payloads are really what we're talking about generally when we're talking about drones. So if some project that you're working on involves a sensor or could involve a sensor, which could benefit from going flying, it might be a thought you have, let's just go, grab a drone, we will attach this thing to it and take it flying. And yes, you may be able to do that. But the commercial stuff you're going to find, the things you're going to go conveniently find are not going to really readily be adaptable for that purpose. So we can help with that. We can integrate those payloads onto platforms. We can help you find the right platform that's the right size, has the right kind of endurance, has the right kind of flight characteristics, and at the best price point for you too, which is of course important. We may very well already have something in stock, as it were, in that stable of aircraft that we can use for you and save you the entire cost of doing that. All we need to do now is integrate your payload onto it. So using those aircraft is a big part of what we can provide. Just talking about that, we can modify those aircraft, we can modify the software and make those aircraft and those payloads marry up. Safety, legality, compliance with the rules. We are very familiar with this, and we can help make sure that your projects are set up so that they will not break any rules, won't get you any trouble with the FAA. So the real lesson here is that early engagement can really help with smooth execution later. I saw this in defense acquisition. When you bring operators into the room at the very front end of requirements generation. So think in your terms, if you're writing a grant proposal, you're starting to think about how am I going to solve this problem? If you think taking something flying might be a way you can help solve the problem you're looking at, I highly encourage, just give us a call. We're part of the university. We're there to provide advice. We can help. Often we can do it, entirely or in part in kind. So it doesn't have to be an expensive endeavor. We just participated in a grant proposal that won one of the grand challenges. That was a joint effort between fire protection and aerospace. And the project intends to spend the next 3 years developing and testing a sensor to help predict the spread of wildfire. So we're going to help take that. We're going to do the part of that takes it flying. And so get something up in the air, try to maximize endurance, try to help figure out how is this thing going to track the advancing fire line and so forth. So that's the kind of thing we can bring to the party. We're not the researchers, but we can facilitate the research. So I talked about this, the organ transfer, that we did. This actually was pretty neat in a lot of ways, because not only did it do that groundbreaking mission, but a few companies spun out of this. So, there was a box. It's literally a cardboard box, but is carrying this ice packed kidney. But when those are carried by humans, they generally go from a storage facility, then they're probably on an airliner somewhere along the line, cars, planes, trains, automobiles, the whole 9 yards. And all that way they're measuring, they're keeping track of temperature and making sure that those things are in good shape. So remote monitoring system was designed for this so that it could be tracked on the ground, and we can make sure that the thing was staying where it needed to be, so that we could abort the mission if necessary and take over manually. And so that technology is now widely used, and it's used even when there are humans. So when they're transporting organs now in vehicles, they're using that same technology to monitor. Mission Go is a company, Scott Plank, the Under Armour brand. So the brother of the founder of Under Armour started up Mission Go in the wake of this. Mission Go as an aircraft that they are designing and building that's designed specifically really for the for this medical transfer, getting certified, trying to get it certified by FAA for medical transfers. Medigo also fell out of this. Medigo is a company that schedules organ deliveries, not just with UAS, but across the country. So their technology, which was originally founded in this project, has now gone national and beyond. And then the Chesapeake UAS route network is another place we're trying to push the boundaries. And I mentioned the rules before. And so here we're trying to move on into the National Airspace System with aircraft in the state of Maryland. So I already talked to you a little bit about some of the projects there. That was the ice thickness measurement. We've done lots of projects along those lines for various agencies over the years. I talked about integrations for private companies as well. Airworthiness. So a big part of safety in drones goes around airworthiness. Is it safe to fly? So when you think about aircraft like you climb into when you're going to go fly home, that thing started from a place of airworthiness, started from thinking about safety. How do we build a safe aircraft? That is really where it starts. Drones typically start with, hey, this is really neat technology. And then later on, somewhere along the way, comes the thinking about how do we do the aviation thing. And so that kind of gets things backward, and safety kind of gets thought of second. And so airworthiness then suffers. And what does that mean? Airworthiness is a way of measuring, the engineering goodness, if you will, of that airframe, making sure that it is a safe aircraft to go up in the air. So we have put together our own methods based on how the DoD does it, scaled down to be appropriate for small UAS to measure them to make sure that they are safe to take flight. And this is just a snapshot of some things we've done. I've talked about a few of these already. Got the medical delivery project, disaster recovery. Some of our team went down to the Bahamas when they had the hurricane a few years ago to help with recovery efforts. This is oysters out in the Chesapeake Bay, working the project out there. There is our sea ice measurement that we talked about. We do a lot of STEM and a lot of outreach down there and all the way up here too. As a matter of fact, if you want to see some of our stuff, we will be set up here on Maryland Day, just down the road here across the street from the Kim building. Airworthiness analysis I talked about. Energy sustainability, I mentioned the solar panel Puma, there it is over here. Communications, so that's that teaming that I talked about. So this was a Navy project. The idea here was, explosive ordnance disposal. You've probably seen or heard of these ground robots that are used to disarm bombs or investigate bombs. And those are run by an EOD technician who is typically close by. So the thought here was, what if we could deploy that ground vehicle with an uncrewed aerial vehicle, then climb back up and relay the data and the communications back to a remote operator, do the explosive ordnance mission remotely, and then go pick up that vehicle and bring it back home and have it ready to go to the next mission. So this was part of a project that we did with the Navy and examined some of that technology. Still kind of ongoing. I mentioned flying in tunnels. That was done for Maryland Department of Transportation. That's a drone inside a round cage. So it can go down tunnels, bounce off the walls, and not crash. Historical sites. If you've ever seen some of these, the stuff that's going on, for instance, down in Central America, where they're looking through the jungle canopies using LiDARs, so, light detection and ranging. We've done that kind of project as well. And then every once in a while we get out of the air vehicle business. And so as part of our search and rescue satellite payload project with NASA, we actually had an unmanned surface vessel that we were using. So we work with DoD, I mentioned that. So you can read that list, but there are a number of areas of interest that we've worked on there. Often these have dual use. So much of this research is directly applicable into civilian purposes as well. That for instance, that project I just described with the EOD, the explosive disposal, has applicability beyond simply military use. This is that project. If you kind of take a look at it, that grounded vehicle is carried in by a UAS. It's deployed. Over the horizon, you've got real-time operation going on by an operator. And then finally, this is a dual use project. This is something that law enforcement could take advantage of as well. And then you could also think about using this very same kind of technology, put a robot down on the ground in a contaminated area to inspect and so forth. We're doing a similar project right now with the Army on that Artemis project, where this is in DARPA, sorry, Defense Advanced Research, a triage product. So they're saying, okay, how can we go out and remotely deploy sensors to do triage of mass casualties? And so let's detect who's alive, who's in need of immediate attention, who's already dead, and who is good enough to come later. So that triage project. And so we'll be using drones for that too. The Chesapeake UAS route network. So if you think of of kind of a highway in the sky, that's kind of the concept here. So we run a backbone for this route network down the Chesapeake Bay. We keep it over water. That's a risk management technique. So that if something happens to one of these, they fall in the water, not on somebody's head. You know, and the idea here is to kind of really push the introduction of UAS into the national airspace. And so on demand, this means you file a flight plan just like you would with a normal aircraft and you go fly. Today, if I want to go beyond the visual line of sight of the operator, I need to first go get permission from the FAA through a waiver process to the rules, which can take weeks or months. So we want to be able to do that on demand. Today, FAA strictly segregates the uncrewed aircraft from manned aircraft. So, you know, you don't get to put them in the same pieces of airspace, same volumes of airspace. So that needs to be resolved as well. We need to find ways to have them operate together. This gets back to that detect and avoid problem. So that's something else we're pushing out here with current. So those kinds of challenges. So it's technology and it's regulation, both that we're working on here. It's a cooperative effort. So we're working with the Navy down at the Potomac River. We'll end up working with the Army up at Aberdeen. We're working with the state of Maryland, Department of Transportation, the Aviation Administration, and, you know, obviously University of Maryland is engaged. We're working with UMass out on the Eastern Shore. And we're also collaborating with other universities around the country. I was just out at Ohio State a couple of weeks ago. North Dakota, University of North Dakota, once it warms up, I'm going out there. And, you know, there's a lot of this kind of work going on around the country. And then ultimately, we want to use this for both public purposes. So think about first responders, and then commercial as well. Not so much that drone dropping a package on your doorstep, but what we call the middle mile for logistics, getting things from distribution center to distribution center. That's where the real utility here is. And so, as mentioned, you know, we look at it kind of a backbone down the bay here. This gets to most of the heavily populated parts of Maryland. And then conceptually, you run segments out to the side, to the east and west to hit areas of concentration. Yep.
No, just
Yeah,
I'm indicating take 5 minutes, maybe then 5 minutes for questions.
absolutely.
I'm sorry, I didn't mean to interrupt. So
That's fine. Okay, real quick then, I'm just going to say, just before I get to the questions, we have internships down in Southern Maryland at the UROC. They run for about 10 weeks over the summer. They're paid internships. And so if you're interested in that, the announcement's out. You know, I can get that to you if you want. I think your professors can as well. But it's a really great project and different from a lot of internships. It's your idea. So you come up with an idea that you think could be solved with drones. You find a faculty advisor to help you out with that. We work together to come up with that idea, propose it to us. If we like your idea, you can end up down there doing that project. We'll give you a budget, we'll give you some money to do it with, and we'll teach you a little bit about project management as well, cost, performance, and schedule. All right, I'm going to stop right there. I've got a video, but I'm not going to run it in the interest of time.
we have, I mean, how long would the video take?
Just a couple of minutes.
Yeah, go ahead and.
Well, this is an intern project. This
Yeah,
is not a
15 minutes left.
Yeah.
So just for everyone aware, we're going to be out of the room before 5 minutes till, so we're good citizens. We need to be wrapping it up by 10 till. That's about 5 minutes from now.
Stuff, yeah.
Okay. So this is my favorite project of the intern projects. This was a UAS that was designed to take off from land in the water, and then swim in the water using the same propeller systems it uses to fly. And that's an important distinction. So people have done these UAVs that land in the water, swim around, and then fly again, but they're normally using two separate methods of propulsion. This was done for under $1,000 by one of our interns several years ago. Pretty neat stuff.
It's pretty cool. Yeah.
It's amazing what you can do. And it worked.
Question.
Yeah, go ahead.
When you said hazmat toxicity kind of projects that you have going on? Do you have anything more specific? What's being done there? Because I know of people who have biosensor projects, and maybe you can put I don't know, like a biosensor on a drone and then fly it into, say, like the fire that was wherever that was. And test.
Yeah, so actually, right now, we're not doing that project right now, but that is an absolutely viable application for a UAS. So the fire is a good example of fire sensor, getting that up in there, that's a hazardous environment. But what I'm talking about is, for instance, think about the Fukushima, disaster several years ago. Contamination everywhere, Chernobyl, contamination everywhere. Humans, you keep them out of there, you get the sensors in, you can put them on ground vehicles, you can go out and investigate what's going on. So that would be one example. It could be chemical spills. You'd want to use UAVs for those. So definitely a sensor such as you described can be flown. It's a matter of figuring out the right integration. And we can help with that.
Yeah, I'll just stand here for the questions.
Yeah. So my research group, we were going to do drones a few years ago in collaboration with engineering. And none of our sites were viable because of the rules that you indicated.
Yeah.
And so what do you think the timeline is for FAA to expand to make this friendlier, I guess? I mean, you mentioned that you're kind of working on it, but do you think this is 5 or 10 years, or is this like?
That depends on which part of the problem we're talking about. So as far as, progress being made on generally getting them into national airspace,
Yeah.
FAA is up for a reauthorization this year. There is a lot of pressure building on them to get off the dime.
Okay.
Now, the problem here in College Park is different, sitting underneath a no-fly zone for drones.
Yeah.
And so that is centered on Reagan National, and unfortunately, we're within a radius here. They can be flown, but you have to go through a tremendous amount of authorization activity to get that waiver from FAA. And it's not just FAA, it's now TSA, it's the Secret Service. There's a whole bunch of wickets you got to. That's why it's so hard.
Yeah, well, we do wetland work, but it was there was just even small airports on the eastern shore, right? I mean, because of the circumference. And so, the fact that they basically don't want you flying anywhere where, like you indicated, where manned aircraft is
And so,
really restrictive.
yeah, if that's something you're interested in doing, you should definitely reach out to us, because that's the kind of thing we have a lot of experience working with. So we operate in the Eastern Shore.
And you can find waivers.
We can go get waivers. The university, as a public entity, has the ability to do some things that some folks can't.
Okay.
You got to go punch the right tickets and go to the right places.
Okay, thank you.
Yeah.
I think we have.
We still have time for a couple of questions.
Yeah, we still
But,
have.
there is a question, Bob Hill online says, we have colleagues out at ARS working with drones, and they've been warned that there may be issues with drones that might have components manufactured in China.
Yes. So anything that's being done for the U.S. government or around critical infrastructure is going to have challenges with some of the commercial or the readily available drones. DJI is the biggest drone manufacturer in the world by far, and that's a Chinese company. All of their data gets sent home, and that's just a fact. And so the U.S. government has banned the use of DJI products without some very strict waivers. And there are a lot of local entities and local agencies that are doing the same. So there is a growing U.S. industry, U.S.-based industry. There is a measure or a certification process, something called Blue UAS, EIU, the Defense Innovation Unit, that runs this thing. And so they basically look at the equipment, certify it as being good to go. And if you build up your aircraft out of those components, you're fine. So there are some aircraft out there that are Blue UAS. Ours in Pax River are in Southern Maryland are Blue UAS compliant, and the ones we're building as custom aircraft are all using, legal components.
I just,
One more question.
One more?
so I want to make a comment, and that is actually from UAS, Stanton Gale, who is one of our extension faculty in Clarksville. So with the private nursery industry, they had used UAVs to fly between the rows of Christmas trees to actually measure the diameter of the trees, so whether they're ready to be cut from a commercial point of view. So there's so many uses. I mean, we can think a lot. So I mean, you heard Travis about the wildlife, for example, migration aspects in Jennifer's area. You know, several of us are in environmental, water resources, precision ag areas. So we had Matt Cicero, prior director, actually in our AI Institute proposal. Unfortunately, we got to number 3 in the nation, but they found the 2. We didn't get the $20 million, but however, they were part of it. So think about proposals and ideas that they can get involved from the beginning, as John mentioned. So with that, John, thank you so much for your time. Let's give another hand.